Okay, good evening. So today's topic, electronic configuration. Electronic configuration. See this is most important. Electronic configuration. What is called electronic configuration? The filling of electrons into orbitals of given atom is called electronic configuration. The filling of electrons into orbitals of given atom. So otherwise, the arrangement of electrons in orbitals of given atom is called electronic configuration. So electronic configuration means the arrangement, the filling of electrons in orbitals of given atom is called electronic configuration. It depends on mainly three principles. The electronic configuration depends on mainly three important principles. Most important these are. First one, half-bow principle. Most important principles, three. Half-bow principle. Second one, Pauli's principle. Pauli's exclusion principle. Simply Pauli's principle. Scientist name here, Pauli's. Hund's rule. Hund's rule. Otherwise principle. Hund's rule of maximum multiplicity. Okay, the electronic configuration is mainly depends on three principles. Half-bow principle, Pauli's principle, Hund's principle, simply. Now, first one. What is called an half-bow principle? So, see, first thing, I have taken half-bow principle. According to here, very simple, half-bow means building up. Half-bow means, see, building up. Half-bow means building up. According to half-bow principle, the electrons are filling into orbitals, increasing order of energies of orbitals, increasing order of energies of orbitals. What is the meaning of that? The electrons are filled first lowest energy orbital. That is called half-bow principle. According to half-bow principle, the electrons are filling into orbitals, increasing order of energies of orbitals, increasing order from lowest to highest. The electrons are filled first lowest energy orbital, that is called Higgs principle. Okay, sir, how to know the energy of orbital? Which orbital is lowest energy? Which orbital is highest energy? How to we are identified? How do we can say energy of the orbital? Very simple. See, the energy of orbital is depends on n plus L value. N plus L value. This rule is also called n plus L rule, where n equals to principal quantum number, that is nothing but shell number. Before I have given principal quantum number, that is nothing but shell number, n value. L equals to azimuthal quantum number. What I have given, where n equals to, what we can take, n, principal quantum number. Principal quantum number, that is nothing but shell number, where L equals to azimuthal quantum number. Azimuthal quantum number I have given for any orbital, for any s orbital L value 0, for any p orbital L value equals to 1, for any d orbital L value equals to 2, for any f orbital L value equals to 3, and so on. Now here, according to m plus L rule, according to n plus L rule, if n plus L value is low, the orbital energy is always low. What about that? If n plus L value is low, the orbital energy is also low. For example, say what I have given, if n plus L value is low, orbital energy is also low. N plus L value is low. The orbital energy is also low. For example, say I have given 1s orbital and 2s orbital. I have given two orbitals, 1s, 2s. Out of two orbital, which orbital energy is low? Which orbital energy is high? Very simple. First, n plus L value. We find out n plus L value, both cases. See here, what is the n plus L value? First, 1s orbital. What is the n value here? 1. N is nothing but principal quantum number. That is nothing but shell number. What is the n value here?
1.
Very good. 1. What is the L
1.
value? L value.
0.
Very
0.
good. 0. Excellent. See,
0.
for any s orbital, L equals to 0. It is a s orbital. So L value equals to 0. Total, that is equals to 1. Okay, see here, with respect to this orbital, 2s orbital, say what is the n value here?
2.
Very good.
2.
N value 2.
2.
What is the
Two.
L value?
0.
0.
Zero.
Any S
Zero.
orbital L value 0. What is
One.
the total? 2.
Oh, 0.
2.
See, now
2.
out of 2 orbital, which is the lowest energy? 1s
1s.
orbital.
1s.
If n plus L value is low, orbital energy also low. So what is the energy order? 1s is less than 2s. 1s is less than 2s. For example, one more. If I have given 2s orbital and 2p orbital, say that which is less energy, which is more energy. I have given 2s orbital
2p more
and
energy.
2p orbital. Okay, n plus L value find out now. Here also n plus L value. What is the n value here? 2. What is the L value?
0.
What is the L value here? 0.
0.
That is so equals to 0. What about here 2p orbital? N value 2. What is the L value?
2. 1.
Any p orbital L equals to
1.
1.
1.
Therefore, total 3. What is the energy order? 2s is less than 2p.
Less
If
than 2.
lowest n plus L value, lowest energy orbital. For example, one more important example. See, if I have given 3d and 4s orbitals. 3d and 4s orbitals. Say what is the energy of the orbitals, which is low, which is high. See,
High.
find out n plus L value. Here we want n plus L value. So here n value how much?
3.
Very good. What is the n value? 3.
3.
What is the L value?
2.
Very
2.
good. 2. L value 2. How to change L value? For d orbital, L equals to 2. Total that is equals to how much?
2.
5.
5.
Okay, say here 4s orbital. What is here n value?
4.
4.
4.
Very good. Plus, what is the L value?
0.
0.
0. S orbital
0.
is given 0. That is equals to 4. Okay, out of 2 orbital, what is the energy order? Energy equals to. What about that? 4s is less than 3d. Am I right?
3.
3d
Yes.
orbital having higher energy. That is correct or not?
Yes.
Correct. So, first lowest n plus L value, that is the low energy. So here, this energy is the low compared to 3. Right? Now, one of the important examples, see, if I have taken 2p and 3s, it is most important. So here 2p and 3s. Say what about that? Energy of
Energy
orbitals.
n equals to 2
N
equals
plus L
equals
value. N plus L value. Say this. What is the very good? What is the N value? 2. What is the L value
2.
here?
1.
2.
1.
1.
Very good. Here, what is the N value there?
3.
3.
3. What is the L value there?
Plus 0.
0.
0.
What is the total? 3.
0.
3 plus 0,
3.
3. Now see here, very important point here. If we know about this rule, n plus L value is low, orbital energy also low. But here, both orbitals having same n plus L value. Same n plus L value. Now, in this case, how to say which is low energy, which is high energy? See, if two orbitals have, if two orbitals have same n plus L value, same n plus L value, in that case, lowest energy belongs to low n value orbital. Lowest energy belongs to low n value orbital. Understood that rule? When it is applicable,
Yes.
when it is applicable, if both
In
orbitals are having same n plus L values,
equal values.
if same equal n plus L values, in that case, which orbital having low n value, that is the
2p
low
orbital.
energy. Okay, therefore, what is the
2p.
energy here?
2p orbital.
Very good. 2p orbital is lower energy than 3s. Okay, these two rules are most important. What I have given? So, electronic configuration means I have given the filling of electrons into orbitals of given atom is called electronic configuration. This electronic configuration mainly depends on three rules, nothing but principles. First principle, Hofbauer principle. According to Hofbauer principle, the electrons are filling into orbitals of increasing order of their energies. What is the meaning of that? The electrons are first filled lowest energy orbital, lowest to highest energy. The electrons are filled from lowest orbital to highest energy orbital. So increasing energy of orbitals. Okay, how to know orbitals energy? So we can say based on n plus L value. First rule number 1. If n plus L value is low, orbital energy is also low. Second point. If two orbitals have same n plus L value, in that case, low n value, low energy, low n value. Orbitals may, which is the lowest n value, that orbital belongs to lowest energy. Understood that? N plus L rule, where n equals to principal quantum number, that is nothing but shell number. L equals to azimuthal quantum number. For any s orbital, L value 0. For any p orbital, L value 1. For any d orbital, L value 2. For any f orbital, L value 3. Now, so energy order. Now I will give energy order. See, energy order. Okay, now energy order. First, say 1s is less than 2s. Out of orbital, lowest energy belongs to 1s, followed by 2s, followed by 3s, followed by 3p, 3s, 3p, followed by 4s, 4s, followed by 3d. After 3d, 4p, after 4p, 5s, after 5s, 4d, after 4d, 5p, after 5p, 6s, after 6s, okay, 7f, 4f, whatever that, etc. See, now, so here it is very difficult for identifications, how to by this. So 1s is less than 2s, 2s is less than 3s, 3s is less than 3p, 3p is less than 4s. How to we are identified? How to say this? So here by heading system no use. I will give one diagram. See this. 1s. So write down like 1s. First shell contain only one orbital. 1s, 2s, 2p, 3s, 3p, 3d, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6d, 6d, now decreasing, 7s, 7p, and 8s. See this, I have taken like this. Okay, now. So the lowest energy, lowest to highest. See, first this one, lowest, 1s. Followed by, we will do like this, 2s. Next, see this, 2p, 3s. Next, what about that? Like this. Next, like this. Next, like this. Next, like this. Next, like this. See. It is the order. Very simple. Say it is correct or not. How to we can say? First, 1s. 1s are the lowest energy. Otherwise, you find out n plus l value. 1s. Followed by 2s. They know that. Followed by, this is the order. Followed by 1s, 2s. Then what about that? Oh, here 1s, 2s, 2p lena. 2p. Followed by 3s. Now see. 3s less than 3p. I will look 1s. Yes. Then 2s. Then 2p. Then 3s. Then 3p. Then what about that? 4s. After 4s, what about that? 3d. After 3d, 4p.
3D.
After 4p, 5s. After 5s, again 4d. After 4d, what about that? 5p. After 5p, 6s. After 6s, what about that? After 6s?
4F.
Very good. 4f. After 4f,
4F.
followed by
5D.
next.
5D.
Next
6p,
6p. Next
6,
6p,
7,
7s,
7s. Next
7s,
5f.
5f,
Next
5f,
next
6d,
7p. Next
7p,
8s. Last 8s. It
8s,
is enough. We have only periodic table में 118 elements are there. Maximum number of electrons are 118 only. So it is enough. This diagram. If you know this diagram, we will say which is the lowest energy, which is the highest energy. It is also according to m plus L value only. No problem. आपको doubt है तो check करो. Here also we followed n plus L value 100%. Lowest n plus L value, low energy. If n plus L value is equal, low n value, low energy.
Sorry, your voice is breaking.
Okay, now say. So here n plus L value based this. First, how we can draw this diagram? Understood that? So first we can take 1s followed by
Yes,
what
sir.
we can take. Okay, it is given in 10th class also, na? Given or not?
no,
Okay, how to represent? Very simple this representation. So it is also given based on n plus L